Welcome to the Silica Exposure Training for the cut stone industry. This training covers the identification, evaluation, and control of silica exposures in cut stone and stone fabrication industries. This training was developed by Georgia Tech's Safety, Health, and Environmental Services Group with funding from the U.S. Department of Labor's Susan Harwood Training Grant Program. This is Lesson 1, What makes engineered stone different from other cut stone products? There are plenty of options when selecting countertops and other stone surfaces. One of the most popular types of countertops right now are quartz countertops. During the fabrication process, dust generated may have varying levels of what we call respirable crystalline silica, based on the types of slab being processed. Stone slabs may contain up to 95% crystalline silica. The highest silica levels are associated with engineered stone countertops. These types of countertops may contain anywhere from 40 to 95% silica, depending on the type and other adhesives and additives. Silica content is generally lower in natural stone products. Calcium-based stones, including limestone and certain varieties of marble, contain little to no silica. In contrast, granite can contain anywhere from 25 to 60% silica, depending on the source of the stone and the location where it is quarried. This table shows the typical silica quartz content of common, natural, and engineered stone slabs used to manufacture countertops. Let's watch a clip of Ever describing what it is like to work with both natural and engineered stone.
Y yo personalmente, en el tiempo que trabajé, pude sentir la diferencia entre un engineered stone y un natural stone. Que el engineered stone hasta arde la nariz.
From the clip we just watched, Ever noticed a difference when the company started fabricating engineered stone countertops. However, let's look at what makes engineered stone so different from natural stone. First, engineered stone is often referred to by lots of different names, such as quartz countertops, the brand name of the specific manufacturer of the stone slabs, or the style in which the slabs are designed. However, the process of making these types of slabs all originates from an engineering design, hence the name engineered stone. A basic overview of the process includes taking quartz rock and crushing it down into a powder, then bonding it together with resins, pigments, and other additives. Let's take a look at an excerpt from an engineered stone slab safety data sheet. In sections 2 and 3, which covers the hazard identification and composition of the material, we can see that there is a health hazard by the symbol that shows what looks like an exploding lung. We can also see the material includes a mixture of crystalline silica, or quartz, titanium dioxide, cristobalite, which is a form of silica, other natural stone pieces, and a polyester resin mixture. This means that the silica content is somewhere between 90 and almost 100% when you combine both the quartz and cristobalite forms of silica. So how do we end up with slabs in a fabrication facility? The manufacturing process begins with selection of raw quartz materials. They are crushed and blended in a unique ratio of quartz, polyester resin, and other additives. The mixture is then compacted into slabs by some form of vacuum and/or vibration process. This process minimizes porosity and reduces water absorption. The slabs are then cured in a kiln at a specified temperature and duration based on the mixture. The curing process may be accelerated by using ovens or steam. When curing is completed, the slabs are gauged, calibrated, polished, and prepared for packing and sent to countertop companies all over the world. Because the quartz is heated up, this changes the composition of the rock, so it breaks down and grinds much easier. When this is done, the material poses a much greater health risk. Thank you for watching Lesson 1 of the Silica Exposure Training for the cut stone industry, a training on the identification, evaluation, and control of silica in the cut stone and stone fabrication industry. This material was produced under grant number SH37200 SH1 from the Occupational Safety and Health Administration, U.S. Department of Labor. It does not necessarily reflect the views or policies of the U.S. Department of Labor, nor does the mention of trade names, commercial products, or organizations imply endorsement by the U.S. government.